I am testing for ambient gases in what we call the control site, which is an area where we do not have wood buried. This test has already been performed by my colleague over the area where we did have wood buried. I'm doing this neutral space so that we can compare the results. And when you have your test area and your control area and you compare the two, you can discern a great many things. One of the things we hope is that there's no difference. We are using this device in a unique way to test methane and carbon dioxide. Basically, those are the two key gases that are going to emit carbon from our wood vaults. And we're sensing outside of the area whether we're seeing any elevated readings for either of those two gases. And I am using a Li-COR 8710, I think is the number. It is a gas analyzer. It typically measures gases specifically coming through the earth, which is a term we call flux, the flux of the gases going in and out of the earth. We use this to get a very instantaneous measure of that. And it specifically measures our methane in parts per billion, and it will measure carbon dioxide in parts per million. The results from these sorts of tests we can use in writing science papers and reports that will help us better calculate the amount of emissions that comes out of a wood burial scenario such as we have. And typically, when we do our flux measurements, the normal way of using this device, this is solid and it's buried in the ground. And that actually seals on top of it so that air from around doesn't get in. It measures the change in the mix of the gases, which, because this is all sealed up, allows us to calculate very precisely what is coming out of the ground and how fast it is changing the concentration of the methane or the CO2 that we're recording. In this case, we have holes in it so that we can actually get the air that's above the ground, which is it's a different focus area. We want to make sure that there aren't any concentrations or buildup. And by having these holes open, it allows the ambient air to flow through. So it's a very viable way of testing what we call a serpentine pattern over the ground, over the ambient, and getting the GPS coordinates for each of the readings that we take. But it will also tell us if there's any hot spots. We can trace to specifically the spot where we saw levels higher than normal or lower than normal as well. I have to admit it's not the most exciting test I've ever done because it's a lot of repetition. We do very short tests of about 20-second cycles with each placement. But by my calculations, we're going to do about 72 of those. And with the time to move things back and forth and the delays and the recalibration of the machine in the middle, it'll probably take about an hour and 15 minutes to do a 50 by 75 foot area. And I'm actually nearing probably just one more row that I have to do. And we've been at it just about an hour.
It's all really cool.
Yeah. And I explained it all without using the term Ghostbusters once.